Here's a practical problem requiring Pythagoras. Here's a diagram of a ladder. The problem is a ladder is positioned so that it leans on the wall at point A and rests on the ground at point B. That's the blue line segment. It slips such that it now leans on the wall at point C and rests on the ground at point D. That's the red line segment. Form an equation in X and hence find the length of the ladder. The information we're given is that line segment AC is equal to X meters. Line segment OC is 4 times AC. Line segment BD is 2 times AC. And line segment OB is 5 meters. Making use of the distances, AC is equal to X, OC is equal to 4 times AC, so that's 4X, PD is equal to 2 times AC, so that's 2X, and OB is equal to 5 meters. Now I'm going to duplicate the diagram and I'm going to separate the information. So on the upper diagram I'm going to show the blue ladder and the associated distances, and in the lower diagram I'm going to show the red ladder and the associated distances, and then we're going to use Pythagoras on each of these two right triangles to gain an expression for the distance. Starting with the upper diagram, using Pythagoras, a squared plus b squared equals c squared, where c is the longest side, the hypotenuse, we get 5 squared plus, in brackets, 4x plus x, close brackets, squared is equal to the length of the ladder, L squared. Simplifying that, we get 25 plus 25x squared as an expression for the length of the blue ladder, which is the same as the red ladder. Moving down to the lower diagram, using Pythagoras again, we get for the base 5 plus 2x all in brackets squared plus 4x all in brackets squared. Expanding that, we get 16x squared plus 25 plus 20x plus 4x squared. Collecting like terms, we get 20x squared plus 20x plus 25 as an expression for the square of the length of the red ladder, which is the same as the blue ladder. Now all we need to do is equate these expressions. Solving for x, 20x squared plus 20x plus 25 is equal to 25x squared plus 25. Cancelling out, 20x is equal to 5x squared, or x is equal to 4. Now that we've solved this for x, let's plug that into the diagram so we can see the actual length of the ladder. We'll start with the upper diagram with the blue ladder. First of all, from this we have on the vertical axis x and 4x, and on the horizontal axis a distance of 5. So given x is 4, 4x is 16, x is equal to 4. Plugging that in using Pythagoras, we get 5 squared plus bracket 16 plus 4 bracket squared. That gives us 25 plus 400, 425. So the ladder has a length of square root of 425, or approximately 20.62. Using the lower diagram, just to verify, the vertical height there is 4x, or 16. The horizontal distance there is 5 plus 2x, or 5 plus 8, or 13. So plugging that into the formula, we get 16 squared plus bracket 5 plus 8, close bracket, squared, which is 256 plus 169, which again is 425. So once again, the length of our ladder is the square root of 425, or 20.62 meters.